Hi, and welcome to this video on reflections. Okay, so hopefully you've watched the other two videos on translations and dilations. So this one is on reflections. So what does that mean? Well, all the reflections that we're doing are reflections about the x value. Okay, so basically that means that we're taking the x value and we're applying a negative to it, right? So reflection involves a negative or negating a value. Okay, so we're going to negate something. So that means we're going to make it opposite if we're going to reflect, right? When you look in a mirror, on the other side, you see a reflection of you, which is basically the same features, right? But just turned a different way. Okay, so we have a negative, right? So this function is y equals negative inside brackets x squared. So the parent function is y equals x squared, okay? So the negative does not normally go with y squared. So this is a quadratic. So it should look like a parabola. So that tells you what the original parent function is going to look like. Well, the negative inside to x, right, whatever we do to x, right, it's going to change it horizontally. So if we change something horizontally, right, that means what's on this side is going to go to this side, and what's on this side is going to go to that side, right? So basically this one is going to be reflected about the y-axis. Okay, so let's see what that means. All right, so let's graph our parent function. So parabola again. All right, so then let's draw our parabola here. All right, so then now what we're going to do is we're going to apply the transformation. So the transformation tells us to reflect it about the y-axis. So that means that every point, and actually let me draw this parabola a little better, right? So when we get to 3, it's at 9. So let me make those points a little more visible. So it should look like this. That's a little better. All right, so let's see what's going on with these points. Well, since we're applying something to x, if x is positive, right, it's now going to become negative. So that's going to come all the way over here, and that point's going to come there. And at the same time, this point that's negative is actually going to become positive, so that's going to become there. And the same thing is going to happen for each point, right? The y values are not changing, they're staying the same. So x is going to be reflected here on this side to -2, and -2x is going to be reflected on this side to a +2. And so that's going to happen all the way down. They're just changing places. So when you get the final function, it actually ends up looking exactly the same. It looks like nothing really changed, but actually it did, right? All your x values that were positive are now negative, and all your x values that are negative are now positive, okay? So that may not be as apparent to quadratic and absolute value. So I'm actually going to skip this absolute value in because we know that the same thing is going to happen, right? We have absolute value is 1 to 1. Okay, maybe I won't skip it, but I'll go through it quickly, right? The same thing is going to happen. Absolute value is 1 to 1. And so this is the parent function. So this is y equals the absolute value of x. And so the prediction is that it's going to be reflected about the y-axis. So all these values are going to come over here, and all these values are going to come over here. And so we interchange, right? So this one goes over here, this one goes over here. So we get a function that's basically graphed right on top of the parent function. So it ends up looking the same. So the gray one is y equals the absolute value of -x. So it's not that it stays the same, but it looks the same. But you guys, your focus is actually on what's happening. So looks can be deceiving, so we don't want to base what's happening off of looks. But now let's look at one that's not symmetrical. Okay, let's look at the let's look at the exponential. So we have an exponential function here. And so exponential is y equals, since the base is 4, it's going to be 4 to the power of x. Okay, so y equals 4 to the power of x. Let's graph that one. Actually, we know that the reflection is going to reflect over or about the y-axis. Okay, so we have 4 to the -2 would be -1/16, which is really, really tiny, and you can't really see it. And then 4 to the -1 would be 1/4. It's tiny as well, but not as tiny as 1/16. 4 to the 0 is 1. 4 to the 1 is 4. So 1, 2, 3, 4. And then 4 to the 2, it would actually be 16, and it's off the charts. It's like somewhere way up here. All right, so we can't get that one very accurate, but let's see what that's going to look like. Well, what's going to happen to all of our values, and let's make that a little more round. What's going to happen to all of our values is that all of our y values are going to stay the same, but all of the x values are just going to be reflected about the y-axis. So this 1/16 is just going to become, so wherever this is -2, this is -1, right? And this is 1 and 2. So this value will come here and look and be there, and then this value would be, this 1/4 will actually be at 1 instead of -1. And then, of course, 0 will stay where it is. And then this 1, which is 4, is going to come over here to -1/4. And then the same thing will happen to this one that's way up here at 16, right? It'll go somewhere up here. And so what you'll have is a reflection about the y-axis. So reason is because if you split down the middle of the y-axis, right, you get the reflected image, and with the reflected image, or the reflected function and the parent function, it looks like a mirror image of each other, right? So everything that was on the positive side, or everything that was on the negative side here came to the positive side, and everything that was on the negative side, the positive side here came to the negative side, all right? So the same thing happened over here, right? But it's harder to see. All these values that were here jumped over here, and all these values that were here basically jumped over here. And then the same thing happened with this. These values jumped here, and then these values jumped here. Okay? So that's basically all that's happening. So there's no need to fear once you get what really can happen to x, right? So we've talked about translation. So x can be translated, shifted left or right. X can be dilated, which means that the size changes, right? So it's stretched, or it's shrinked, or squished, whichever word you prefer. Or it can be reflected, right? Which means that it's turned around to face the opposite direction. All right, so I hope this video has helped, and I hope that it will help you with your homework. And tune in for the next one. We'll do one where we have mixed things that we have to actually do, okay? Mixed transformations.